The International Space Station (ISS) has been a symbol of international cooperation and scientific research since its first module was launched in 1998. Orbiting Earth at an altitude of approximately 400 kilometers, 250 miles, the ISS provides a unique environment for research in microgravity and has been home to astronauts from various space agencies. However, operating a space station in low Earth orbit comes with a variety of challenges, both technical and logistical. One of the primary challenges facing the ISS is its aging infrastructure. Originally designed for a 15-year lifespan, the ISS has now been operational for more than 2 decades. Many of its modules and systems are beginning to show signs of wear and tear. Critical components such as solar panels, life support systems, and power supply units are subject to gradual degradation due to prolonged exposure to the harsh environment of space. The ISS relies on solar panels to generate electricity, but over time, these panels become less efficient due to damage from micrometeoroid impacts and the continuous bombardment of space radiation. Replacing or upgrading the solar panels is a significant logistical challenge. The station requires constant maintenance, and astronauts often conduct spacewalks to repair or replace malfunctioning equipment. However, these spacewalks are risky and resource-intensive. As the station continues to age, the need for repairs is expected to increase. Space debris poses a significant risk to the ISS. The station orbits the Earth in a region of space known as low Earth orbit (LEO), which is increasingly congested with fragments of defunct satellites, spent rocket stages, and other debris. Even small pieces of debris, traveling at speeds of up to 28,000 kilometers per hour, 17,500 miles per hour, can cause significant damage to the station. To mitigate the risk of collision, the ISS is equipped with radar tracking systems that monitor space debris. When necessary, the station can perform collision avoidance maneuvers to change its orbit and steer clear of dangerous debris. However, as the amount of space debris continues to grow, these maneuvers are becoming more frequent, adding complexity to mission planning and increasing fuel consumption. The ISS depends on regular deliveries of supplies such as food, water, and equipment from Earth. These supplies are delivered by spacecraft such as Russia's Progress and the United States' SpaceX Dragon and Northrop Grumman's Cygnus. However, the station's reliance on these resupply missions presents several challenges. A failed resupply mission, due to a rocket malfunction or other issue, can create significant problems for the station's operations. While the ISS is stocked with reserve supplies, delays in resupply can force astronauts to ration food or delay scientific experiments. As space agencies prepare for longer missions beyond low Earth orbit, such as those to the Moon or Mars, the reliance on frequent resupply missions will need to be reduced. The development of more self-sustaining life support systems, such as water and oxygen recycling, is crucial to address this challenge. Microgravity-related issues. While the ISS offers a unique environment for research, microgravity also creates challenges for both astronauts and equipment. Health of astronauts. Extended stays in microgravity lead to health problems for astronauts, such as muscle atrophy, bone density loss, and fluid shifts that can affect vision. Exercise regimens and nutritional plans are in place to mitigate these effects, but the long-term impact of living in microgravity is still being studied. Equipment performance. Some equipment does not function as effectively in microgravity. For example, fluids behave differently without gravity, which can affect the performance of cooling systems and other machinery. Engineers must design specialized equipment to operate in space, which increases the cost and complexity of the station's systems. International coordination. The ISS is a collaborative project involving multiple space agencies: NASA United States, Roscosmos, Russia, ESA European Space Agency, JAXA Japan, and CSA Canada. While this international partnership is a testament to global cooperation, it also presents challenges: political tensions. Geopolitical tensions between countries, particularly between the United States and Russia, can affect collaboration. For example, sanctions or diplomatic conflicts can complicate the sharing of resources or the coordination of missions. Coordination of research. With so many nations involved, prioritizing research projects can be a challenge. Each space agency has its own objectives and goals, and the limited time and resources available on the ISS must be carefully managed to ensure that all partners can benefit from the station's capabilities. Funding and future plans. The ISS is expensive to maintain, costing billions of dollars annually. As the station ages, the question of funding becomes more pressing. While the ISS is expected to remain operational until at least 2030, space agencies are already discussing what will come next. Private sector involvement. NASA and other space agencies are exploring partnerships with private companies to share the financial burden of operating the station. Companies like SpaceX and Boeing are already providing transportation services to the ISS, and there are plans for private modules to be added to the station or for entirely new commercial space stations to be built. Decommissioning. Eventually, the ISS will reach the end of its operational life. Decommissioning the station and safely bringing it down to Earth presents significant challenges. The station's descent must be carefully controlled to ensure that it burns up in the atmosphere and any surviving debris lands in a safe location, usually over the Pacific Ocean. The International Space Station, ISS, serves as a cornerstone of scientific research and international collaboration in space. Yet, it faces formidable technological and scientific challenges that must be addressed to maintain its efficacy and relevance. As technology progresses, the ISS must continually be equipped with the latest innovations. This encompasses upgrading computers, communication systems, and research apparatus. The process of installing and integrating new technologies into the station's existing framework is intricate, necessitating meticulous planning and execution. Furthermore, the unique microgravity environment on the ISS offers unparalleled opportunities for scientific exploration, though it does bring about certain constraints. Some experiments are simply not feasible in space, while others demand significant modifications to suit the space environment. Scientists are challenged to exploit the ISS's unique conditions while grappling with its inherent limitations. Despite these obstacles, the ISS continues to be an indispensable platform for groundbreaking research. Addressing the technological and scientific hurdles is crucial to extend the life and success of this floating laboratory. Moving forward, space agencies and private entities must collaborate to devise innovative solutions. The mission is not merely to sustain the ISS, but also to solidify its legacy as a pivotal element of space exploration. Overcoming the array of challenges, from aging infrastructure to the peril of space debris, is essential to ensure the future success of the ISS and its contributions to humanity's quest for knowledge.